Hello students, let's do speed, distance and time, exercise 12b. Page 142, question 11. Two cars start from the same place with speeds 80 kilometers per hour and 50 kilometers per hour. Find the distance between the two cars at the end of 3 hours if they are going in the same direction. This is the first question. So here we have two cars. Their speeds are 80 kilometers per hour and 50 kilometers per hour. Now we have to find the distance. Okay, now what is the formula to find distance? Distance is speed into time. Now here we've been given two speeds, isn't it? That means we have to find the relative speed. Okay, because here it says find the distance between the two cars. Between the two cars at the end of 3 hours. So we have to find the relative speed. Only if we get that speed can we find distance, because time is already given to us. So now we have learned about vehicles that go in the same direction. We can find their relative speed. Now how do we do that? Now if you take vehicles that are going in the same direction, then the relative speed is the difference in speeds. So here they're going in the same direction. So if I have to find the relative speed, I just have to minus these two. I have to minus the two speeds and I will get the relative speed. So let's do that. Relative speed is difference of the speeds. So difference of the speeds means we have 80 kilometers per hour, the first car, and then we have 50 kilometers. So we subtract both 50 kilometers per hour. When you subtract 80 minus 50, you get 30 kilometers per hour. So now that we have found the relative speed, we can find the distance. So let's find the distance. Distance is speed into time, and speed is 30 kilometers per hour. So 30 kilometers per hour into time is 3 hours. So both are in hours, so there's nothing to worry. We just have to multiply. So when you multiply both, you get 30 into 3. 3 threes are 9. So 30 into 3 is 90. 90 kilometers. So here we have 90 kilometers, which is the distance at the end of 3 hours if they're going in the same direction. So let's answer the question. The question is, find the distance between the two cars at the end of 3 hours. So at the end of 3 hours, the distance between the two cars will be 90 kilometers, and because they're going in the same direction. So if they're going in the same direction, the difference is 90 kilometers. Now we have to find the same thing when they're going in the opposite direction. So here we know to find relative speed in the opposite direction, we have to add up the speeds. So here let's write relative speed is sum of the speeds, and the speed of the first car is 80 kilometers per hour and the speed of the second car is 50 kilometers per hour. So we add up the two speeds here because they are going in the opposite directions. So when you add this up, you get 80 plus 50, 130 kilometers per hour. So we have found the speed. Now we can find the distance. So distance is speed into time, and speed is 130 kilometers per hour and time is 3 hours. Again, they are the same unit, so there's nothing to worry. We just have to multiply 130 into 3. So multiply 13 into 3. 13 threes are 39. Now add the 0. So 390 kilometers. This is the distance between the two cars when they are going in the opposite direction. So the answer here is 390 kilometers. Question 12. A train 80 meters long passes a platform 220 meters long. If the speed of the train is 45 kilometers per hour, find the time taken by the train. So the train is passing a platform and we know the speed at which it is passing, but we don't know the time and we have to find the time. Now what is the formula to find time? Time is distance by speed. That means we need to know distance. Is distance given in the question? Distance is not given, but the length of the train and the length of the platform is given. Is speed given? Yes, speed is given to us. Now we have to find the times. That means we need to find the distance. And we have learned that when a train passes a platform, the distance covered will be the length of the train plus the length of the platform. So keeping that in mind, let's work out this problem. So let's begin by writing what is given to us. The speed of the train is given to us 45 kilometers per hour. Now you need to be very careful when you look at the units. Now here it is 45 kilometers per hour, but if you look elsewhere, you'll see that the length of the platform and the length of the train are in meters. So let's convert this kilometers per hour into meter per second. So that will be simple. That is 45. When you convert it into meter per second, all you have to do is multiply it by 5 by 18. Now here let's cancel what we can. Now I can cancel 18 and 45 by 9. 9 twos are 18, 9 fives are 45. Now let's multiply the numerators because there's nothing else to cancel. So 5 fives are 25, 25 by 2. Now this has become meter per second. So here the speed of the train is 25 by 2 meter per second. So we'll leave it at that. Let's continue. Now keep this point in mind that the distance covered by a train when it is passing a platform will be the length of the train plus the length of the platform. And remember, we need to find distance, so we're going to make use of this formula. So here distance covered by the train is length of the train, which is 80 meters, plus the length of the platform, which is 220 meters. 800 meters plus 220 will be 300 meters. So this is the distance covered by the train. So now we have the speed 25 by 2 meter per second, and we have the distance 300 meters. Both the units are the same. Now we can find the time taken, that is distance by speed. So distance by speed, distance is 300 meters, and this is by 25 by 2, which is the speed. So this can be written as 300. Now by 25 by 2 means divided by 25 by 2, isn't it? So now I can write this as 300, change division into multiplication and write the reciprocal. So 2 by 25. Now we can cancel. 25 into 12 is 300. Okay, so 25 into 1. Now multiply the numerators. 12 twos are 24. And since this everything else is in meters per second, since we are looking at the time, this is 24 seconds. So what have we found? We have found the time taken, and that is 24 seconds. So we have found this also. We've been asked to find the time taken by the train, and the time taken by the train is 24 seconds. Question 13. The speed of a bus is 90 kilometers per hour and the speed of a truck is 72 kilometers per hour. So we are talking about a bus and a truck. They're moving at different speeds, but both start from the same place. Now the question is, find the distance between the two after 20 seconds when they go in the same direction. So first we need to find when they go in the same direction. So what is given to us? The speed of a bus, the speed of a truck, and the time is given to us. Now what are we asked to find? Distance. And what is the formula to find distance? Distance is speed into time. Now here we've been given the speed, but it's speed of two vehicles. That means we're talking about relative speed. So remember, when it is the relative speed and they are moving in the same direction, keep this in mind. It will be difference of the speeds. So when they are moving the same direction, relative speed will be difference of the speeds. That means subtract the two speeds. Then you will get the speed. Now time is already given to us. So first let's find the relative speed. Difference of the speeds means the first speed, that is speed of the bus, is 90 kilometers per hour and the speed of the truck is 72 kilometers per hour. We have to subtract the two. When you subtract, you will get 18 kilometers per hour. So this is the relative speed. Now look very carefully and see. Speed we have found in kilometers per hour, but the time is in 20 seconds. So kilometers per hour and 20 seconds. Remember, it's always easier to convert from the big to the small. From hour to second, it's easier. Now 18 kilometers per hour, we can convert to meter per second. Now, how do we do that? We say 18 kilometers per hour when you multiply it by 5 by 18. Okay, so let's multiply. So here I have cancelled off the 18s. So what is left is simply 5, which has now become 5 meter per second. So I have found the relative speed in meters per second. Now I can use it because this is in meter per second and time is also in seconds. So now it's going to be easier to work with this. Let's find the distance. The formula to find the distance is speed into time. And speed we found is 5 meter per second and time is given to us in the question 20 seconds. So now let's multiply the numbers 5 into 20. 5 into 20 is 100 and we're finding the distance, so the unit is meters. So what is our final answer? 100 meters. So this is the distance between the two vehicles after 20 seconds when they are moving in the same direction. Now we need to find the distance between the two after 20 seconds when they move in the opposite direction. So here also what's given? Speed of a bus is given, speed of a truck is given, time is given, and we know that when they are moving in the opposite direction, relative speed will be sum of the speeds. That means we have to add up the speeds. So let's find the relative speeds. So here will be 90 kilometers per hour plus 72 kilometers per hour. Remember, we are adding up here because they are moving in the opposite direction. So when you add up these two numbers, you get 162 kilometers per hour. Now this is in kilometers per hour. We're going to convert it to meter per second. So we have to do 162 into 5 by 18. So here I can cancel 18 and 162. 18 into 9. 18 ones are 18. 18 into 9 is 162. So multiply the numerators. 9 fives are 45. So now I have 45 meter per second. So I have found my relative speed, 45 meter per second. Now I need to find the distance. Distance is speed into time, and speed is 45 meter per second into time is given to us 20 seconds. So we have to multiply 45 into 20. 45 into 2 is 90. So into 20 will be 900. And since we are finding the distance, the unit is meters. So what is our answer here? The distance between the two vehicles when they move in the opposite direction is 900 meters. Question 14. A train passes a 50-meter long railway platform in 4.5 seconds and a pole in 2 seconds. Find the length of the train and its speed. Now let's recollect something about a train passing a platform and a pole. Now we have learned that if a train has to cross a pole, then the distance covered by the train is equal to the length of the train. The distance is equal to the length. And here we are talking about a train crossing a pole in 2 seconds. That means the distance covered in 2 seconds is equal to the length of the train. So keep this in mind. Now, to cross a platform. To cross a platform, the distance covered by the train is equal to the length of the train plus the length of the platform. You've learned this earlier, isn't it? So here the distance covered in 4.5 seconds is equal to the length of the train plus 50 meters. What is 50 meters? It is the length of the platform given to us. So distance covered in 4.5 seconds is equal to length of the train plus 50 meters. Now how do we get this length of the train? Now if I have to take this as an equation, I can't say length of the train is equal to distance covered in 4.5 seconds plus 50 meters. No, because it's going to be different units, completely different. So I'm going to write, instead of length of the train, look at this here, length of the train is given to us as distance covered in 2 seconds. So instead of length of the train, I'm going to write distance covered in 2 seconds. So now what do I have? Distance covered in 4.5 seconds on the left hand side. On the right hand side, I have distance covered in 2 seconds. Where did I get that from? Here. length of the train is equal to distance covered in 2 seconds plus 50 meters as it is. Now I can have this as an equation because on both sides I have distance covered. Okay, so what I'm going to do is I'm going to move this to the left hand side. Okay, from the right hand side, I'm going to move it to the left hand side. When it goes to the left hand side, it becomes subtraction. So let's write that. Distance covered in 4.5 seconds minus the distance covered in 2 seconds equals 50 meters. So I have moved this from the right to the left, and now it's become minus. So now I can minus 4.5 seconds and 2 seconds. So let's minus that and see. 4.5 minus 2. Let's convert this. 2 fours are 8 plus 1 is 9. 9 by 2 minus 2. So here let's give this the denominator 1, and here our LCM is 2. 2 ones are 2, so 9 ones are 9. So this is 9 minus, here it is 1 into 2 is 2, so 2 into 2 is 4. So here 9 minus 4 is 5. 5 by 2, let's convert this. 5 by 2, let's convert it to an improper fraction, to a mixed number. 2 2s are 4 minus 1. So this is 2 1 by 2, or 2.5 seconds. So what have we done? We have subtracted 4.5 and 2. Because it says minus, isn't it? So distance covered in 4.5 seconds minus 2 seconds is distance covered in 2.5 seconds. So let's write that. So that will be distance covered in 2.5 seconds is equal to 50 meters. The same thing. I have put it here. This is equal to 50 meters. Okay, so I hope you've understood till here. Now we have to find the distance covered in 2 seconds. Why? Because we have been asked to find the length of the train. And if you find the distance in 2 seconds, you will be able to find the length of the train. So here you have distance covered in 2.5 seconds. Now you must find the distance covered in 2 seconds. Now does this sound familiar? This has now become unitary method. That means first we have to find the distance covered in 1 second. So the distance covered in 1 second will be 50 meters divided by 2.5 seconds. So that is 50 meters divided by 2.5 seconds. So let's work that out. 50 divided by 2, 1 by 2. So this is 50 by 1. So 50 by 1 divided by, convert this to 2s are 4 plus 1 is 5. 5 by 2. So 50 by 1, division becomes multiplication, reciprocal. So 2 by 5. Now cancel. 5 tens are 50. 10 into 2 is 20. So distance covered in 1 second is 20 meters. We just found out 20. So first we had the distance covered in 2.5 seconds. Then we found the distance covered in 1 second is 20 meters. Now if we find the distance covered in 2 seconds, that will be the length of the train. So let's find the distance covered in 2 seconds. In 1 second it's 20. So in 2 seconds it will be 20 into 2. So 20 meters into 2. 20 into 2 is 40. So we have found the distance covered in 2 seconds, and that is equal to the length of the train. That means we have found the length of the train to be 40 meters. The length of the train is 40 meters. So we have found the first part. The first part is find the length of the train, and we have found it to be 40 meters. Now we have to find the speed. And what is the formula for speed? Distance by time. So distance we have 40 meters and time we have 2 seconds. So let's start with that now. To find speed, we say distance by time, and we found the distance in 2 seconds to be 40 meters. This is when the train passes the pole in 2 seconds. The distance covered is 40 meters. So here let's find the speed. Speed, here it is 40 meters and the time is 2 seconds. Cancel, I can cancel 2 and 40. 2 ones are 2, 2 into 20. is 40. Now this is 2 seconds. So now our speed is 20 meter per second. Now if you have to convert this to kilometers per hour, what do? We say 20 into 18 by 5. So we can cancel 5 and 20, 5 ones and 5 fours are 20. Multiply 18 into 4, 18 into 4 is 72. So here our answer is 72 kilometers per hour. So if you want your answer in meter per second, it is 20 meters per second. You convert it to kilometers per hour, it is 72 kilometers per hour. Now, so that's our final answer. That is, the speed of the train is 72 kilometers per hour. Now, the distance covered in 4.5 seconds. The question says it crosses a platform in 4.5 seconds. That means if you have to find the distance covered, it will be the length of the train plus 50 meters. And we found all this. Now, if you're going to work it out this way also, you will get the same answer, 72 kilometers per hour to find the speed of the train. So whether you use this distance covered in 4.5 or 4.5 seconds, or if you have to use this, where we have used this for this particular part, distance covered in 2 seconds, your answer will be the same, 72 kilometers per hour. Question 15. A train passes a platform 225 meters in length in 21 seconds and a man standing on the platform in 6 seconds. Find the length of the train and the speed of the train. So it's a very similar question to the previous one. Now there also the train passed the platform and there the train passed a pole. But here we are talking about a man standing. So that means a stationary man. Okay, so passing a stationary man or the pole, we use the same method to find. So let's again use this point. If you have to cross, if the train has to cross a stationary man, if the train has to cross a stationary man, then the distance covered by the train is equal to the length of the train. Remember, we are finding out the length of the train. So the distance covered is equal to the length of the train. And here, the distance covered in 6 seconds. You're talking about the man standing on the platform. So 6 seconds. The distance covered in 6 seconds is equal to the length of the train. So keep this in mind, just like the previous question. Now, if the train has to cross a platform, how do we find the distance covered? So here, distance covered by the train will be length of the train plus length of the platform. Okay, so now here what are we going to say? Distance covered by the train when it passed the platform in 21 seconds. So distance covered in 21 seconds is equal to length of the train. We don't know, but we know the length of the platform and we have substituted the value 225 meters. Now look carefully again. We're going back to this first equation that we have done here. So instead of length of the train here, we have been told the length of the train is the distance covered in 6 seconds. So we're going to write the same thing here. Distance covered in 21 seconds is equal to, instead of length of the train, we say distance covered in 6 seconds because it's the same thing. So distance covered in 6 seconds plus 225 meters. Now I'm going to transpose this from the right hand side to the left. I'm going to bring it to the left because both are about distance. So when I move it to the left, it becomes subtraction. From addition, it will change to subtraction. So let's write that. Distance covered in 21 seconds is written as it is. This I have moved it here, so it's become subtraction. Distance covered in 6 seconds is equal to 225 meters, remains the same. So distance covered in 21 seconds minus 6 seconds minus these two. 21 minus 6 is 15. So distance covered in 15 seconds is 225 meters. So again we are back to unitary method because here we are going to find the distance covered in 6 seconds. So first we have distance covered in 15 seconds. That means the next will be distance covered in 1 second. That is dividing this by this. So let's divide 225 meters by 15 seconds. So 15 into 15 is 225. So I can cancel. So that is 225 divided by 15. So cancel 15 into 15 is 225. So I have my first answer here. Distance covered in 1 second is 15 meters. So distance covered in 1 second is 15 meters. Now I'm going to find out the distance covered in 6 seconds. In 1 meter, in 1 second, if it is 15 meters, in 6 seconds it will be 15 into 6. That is 90. 15 into 6 is 90. 90 meters. So the distance covered in 6 seconds is 90 meters. And what is the distance covered in 6 seconds? It is the length of the train. That means we have found the length of the train to be 90 meters. So this is our answer. We have found the length of the train to be 90 meters. Now we have to find the second part of the question, which is speed of the train. To find the speed, we need to know distance and time. So let's do that. So speed is distance by time, and we found the distance covered in 6 seconds is 90 meters. So distance is 90 meters. And the time is also given here. It's 6 seconds. Now you can cancel this 6 and 90. 6 into 15 is 90. So now we have found the speed to be 15 meters per second. Now if we have to convert meters per second into kilometers per hour, multiply that number by 18 by 5. So here we can cancel 5 threes are 15. 3 into 18 is 54. So here, if we convert it to kilometers per hour, we get 54 kilometers per hour. So we have found the speed of the train to be 54 kilometers per hour. Now this, how did we find? We took the case of the train passing the stationary man in 6 seconds. Okay, so in that case, we got the speed of the train as 54. Now, even if you take the distance covered by the train when it passes a platform in 21 seconds and you work this out, your final answer will still be 54 kilometers per hour. So this is our final answer. Whatever you take that is given in the questions, whether it is the distance covered when it passes a platform or when it is passing a stationary man. The speed will be the same. So you can even check this out. You can work this out and see whether you're getting the same answer. So with this, children, we come to the end of this exercise. Thank you, children.